in this problem we have to find the intervals on which the function is increasing or decreasing and where it's concave up or concave down. To do that, first we have to find the domain of the function. Since we have a really nice function, our domain is R, so there is no bad point on our number line. To find where the function is increasing or decreasing, we have to use these rules. For that, we have to find the first derivative of the function, which is 4x cubed minus 4x. Since we have a nice function, we only have to find the zeros of the derivative, so we get an equation like 4x cubed minus 4x equals to 0. Let's factor out 4x. We got 4x times x squared minus 1 equals to 0. Now this is nothing else but 4x times x minus 1 times x plus 1 equals to 0. So our critical points are 0, plus 1 and negative 1. Let's put these numbers back on our number line. Here we have negative 1, here we have 0, here we have plus 1. So we have intervals like here is x smaller than negative 1, here is x between negative 1 and 0, here is between, and here is greater. So we get the table like this. Now we know that our derivative function in these points are zeros, and we have to find the signs in these intervals. To do that, we draw the graph of the function. Since it's a cubic function and we have 3 zeros, it should look something like this. Here is negative 1, here is 0, and here is positive 1. Now we can see if x smaller than negative 1, our graph is below the x-axis, so our function is negative. Between negative 1 and 0 we can see that our function is positive. Here we can see that our function is negative, and here we can see that it's positive as well. Let's put these signs back on our table. Here is negative, here positive, here negative, and here positive again. So according to these rules, our function here is decreasing, here is increasing, here decreasing, and here increasing again. It wasn't the question, but if we connect these arrows, we can see that here we have a local minimum place, here a local maximum place, and here a local minimum place again. So our function should look something like this.